So, what is our mission? Our mission is that's something what is bringing all of us and all of CGM together, so that no one should suffer or die because of missing information. This is what CGM is doing. It is good to understand in that regard because it has implications for the applications and also for the architecture. So we are providing software for medical data in the whole chain, from pharmacies to hospitals and also to doctors. And this was our starting point, and then we sat together and said, hey, yeah, let's offer our business a cheap alternative to VMware, and that was before the Broadcom time. So if it would be in the Broadcom time, it would be a more intensive discussion. Then we thought about open source because we all love open source, and then shouldn't that be easy to do with open source, for the question in mind? And there's this cool thing called OpenStack. It seems like it comes with everything what we need, so let's use it. That was our starting point, and then we started to build our clouds, and very motivated, and the first dilemma came. How do we orchestrate this? We have the strong requirement of multi-tenancy, so the idea is that we have a central team which manages the whole platform, and we have the users which act in their own sphere. And in their own sphere mean in their own environment, in their own company, in their own way of thinking and doing stuff. So that was the idea, and we had the dilemma how to orchestrate everything. We had, I think, quite intense discussions on which is the right way, and we evolved also during the way. We chose Waxhouse Atmosphere because Waxhouse from the beginning was a good partner of us, who helped us a lot with knowledge, but also in support and also to guiding us how to do it, because we were pretty new on this topic and had to learn a lot of things. And it was for us a good choice, and we are still relying on that. So it has some benefits for us, like the native integration with Keycloak, which is important for our enterprise, and but also the lifecycle management, and to having there an organization which we can pay to add new features for us, to add specific features for us, but also to guide us to choose the right technology. And for sure the technical aspects of their solution, I think they're pretty much than this, but this is just a summary of what we experienced at. So the first dilemma solved. We choose Atmosphere. Now we were in the part of thinking about how our architecture should look like. And there are multiple considerations. There are much, much more than this, but this is what we had to think about first. So what kind of data center we need, co-location, dedicated data center, how we design this, the network layer, how should we structure it, where should we do switching and all the part. Multi-tenancy, as said, is a very crucial part in our topic. The medical data our main customers are in Germany, so we are not only in Germany, we are also spread over Europe, but the German regulation is, I would say, the top compliance part there, and multi-tenancy is something where we also have the issue of certifications, so that we have to define from the beginning. For sure, the control plane, OpenStack comes with a lot of solutions and a lot of possible options. There's always an open source, and we have to think what is our flavor and what is our opinion on that. Computing and storage, and for sure the scaling. What we came out is that we created an architecture which we are living until today now. We change it over the time, but this is more or less a short overview. So first of all, we have a control plane. The first decision, which was also made with including Atmosphere, is that we deploy nearly everything in Kubernetes. So for us, our control plane is also living in Kubernetes. We have the other components, the OpenStack services, and we have some shared services which we need. So we need a database, we need something like Keycloak and other components which are a bit too detailed for this, I think. And then we call it the compute plane, compute node. And this is the main part and the important part for our cloud. So currently we are operating around 200 of this bare metal servers, and they are pretty large. So they have They have around 500 CPUs there, or cores, not CPUs. CPUs would be really high, but cores, and they're deployed with the main components as we know. With Nova, we are utilizing Neutron. In the latest, we are also facing with OVN, but there you have also the local part of disk and exporter. Another important pillar of our environment is the storage. We have huge storage requests from our customers and a lot of data to store, and for that we choose Ceph, and for that we also have a control plane and a data plane. We are using there for Ceph, we are using a pretty straightforward setup with the typical mon nodes of Ceph, and then having storage nodes with our specialized hardware, but also containerized. So we are using there also the Ceph container, or the model of having Ceph in containers. And at the end, everything relies on a good network layer. This is what we experience pretty hard. So the network layer is something what should be very robust in this situation, not only for the topic of how the bandwidth is there, but also for the latency, and especially with having the Ceph underneath, which is a network distributed storage, can be an issue. And that is coming from, this is the perfect handover to our lessons learned. So what did we learn through the whole journey? First of all, don't forget the users. It's so stupid, but we did. We forgot them. We don't really forgot them, but we forgot to manage their expectations. So they often compare what you give them with what you know, what they know, or what they heard. And for sure, we were offering them a private cloud. They were thinking, oh nice, we have AWS and Google now in our house, and I can use it as I know. The second thing is they have implicit features in mind. So things they expect that they are working in a certain way, and this is something we missed to manage or to identify early. We did this through the time and correct this afterwards, but from the beginning we didn't thought about it. And this is a learning, because when they expect to have an SSO, this is a feature which we created. But having an auto-scaling for that kind of scaling of Kubernetes and cluster API and how they are using, this is something which we might have discussed earlier. Or their request for storage, that they expect a full-blown backup solution where they can do live migration and live backup, like in VMware, is something which we probably not address so good as they want. So at the end, what expected our users? You can see this picture. I think it's a good analogy. So they expected a full meal, which is nice, nice looking, fancy, and even tasty. To explain this in technical terms, yeah, they wanted a self-service portal for all users. Our users are not all technical, and they're pretty less technical, and they expected a service portal which can everyone use and utilize and understand without reading any kind of documentation. They wanted fully automated, no care operations. So lifecycle management, patching, backups, all this operation part should be handled totally automatically in a magic way, and without effort from their side, so they can put their effort on developing the product. That was one of the implicit features they requested, or they thought of. Always on infrastructure, so everything should be high, working everywhere. Issues, incidents should not exist. They need this governance and compliance by design, or to phrase it better, we need this as an organization, because there are certifications, obligations from the regularity, and for sure they should be also there, and also in a magic way, so that they are all ever verified and met and already incorporated in the platform. That there is a policy-driven security which always looks if there is everything encrypted and secure and gives you the right check mark. And yeah, for sure, elastic resource scaling. They didn't care if we have 1 or 10 hypervisors, and they don't care that we have to wait until this this will be delivered to our data center, and this has to be built in and configured and provisioned and also monitored. This should be there and just working. Ideally with auto-scaling. That was also something what they thought about. And for sure it should be an unbeatable market price. So it is okay, it is a bit too high what they were requesting. But then, what did we offer them? Yeah, what they got is they got not a dish, they got some ingredients. They are very tasty, but it's not a ready dish. So, yeah, they got a self-service portal for all users who know. So it was Horizon. We served them the normal Horizon, and there are some users which are really happy with them. Others, well, though that much unsatisfied that they wrote an UI on top of that to make it easier to deploy VM. Yeah, they expected this full kind of operations, this full automatic part of operations. They got a kind of operation, so we tried our best. That wasn't enough, or that disappointed them, but we did it, and at the end we managed to find a way to understand both better, but that was a learning that that was the different what they expected. Always they wanted that the infrastructure is always running. Yeah, we provided them an infrastructure which is always there. The most time running, and there were also cases when it was not running, to be honest. But we had all components there, like here, the ingredients, and we had very motivated people who helped them very fast. Yeah, governance and compliance, they wanted to be included already. Yeah, we did it per request because we didn't know about that. Policy-driven security, also same there. We have for sure security measures there and also security considerations in the architecture. But what they need at the end from the product or for certification plan is something else, and we added this afterwards because we need first to understand the requirement. We did this not from the beginning. Yeah, resource scaling. Very interesting topic. Yeah, what they got is a kind of resource scaling. We try to manage the hypervisors that we have a bit of spare, so when they request more, we can say, yeah, for sure there is something, and then at the same time we order fastly something more. So it was a balance of manual ordering, capacity planning in advance, and reserving a lot of money and resources for the case that they request more. And they request more, even more than we thought. And price, yeah, they expected transparent prices, unbeatable in the market. Yeah, what they got is they got it right. That's all. That was the first learning from that. So the second learning is never skip the last mile. Yeah, we know that this is crucial. You should think about that, and it's so simple. But I think nearly everyone who is something with technique was in the situation that someone came and said, hey, we have high pressure, let's do what we can do, and we will do this part afterwards. Yeah, that was it. And first, we missed the operational processes, monitoring and scaling. We missed some intention, so we said, okay, we can do this, but then it has implications. Yeah, we did this, it had the implications. But at the end, no one cares about because the users are unsatisfied. So whenever you come in the situation that someone says to you, hey, please, let's go live now, even if you're not ready, or let's do what we can, and then raise your voice against it and fight for that because that is worth. That's at least what we experienced with our journey. We had a lot of afterwork with that. The second the next finding from our side is that finding the right metrics is really hard, especially in the OpenStack environment. Why is it so? There are an overwhelming number of technical services. We have the situation, or you can experience the situation, that every single service of OpenStack is running, and the end user using this platform is not able to deploy VM. We had this situation multiple times. Same here for the balance between detail and oversight. If you go too deep to monitor everything, we will be flooded with messages, with errors, with issues, with things we should consider and are not seeing the real cases. It's really hard to prioritize there. There's a high risk of blind spots, which we also see. This risk comes from a bit from the metric-based monitoring. It's a great tool and we love it. So doing Grafana dashboards and identifying metrics is something which we really enjoy and gives us a good overview. But there is this point of the blind spots. So there are situations when you do not have the right configuration. Probably an exporter is not there anymore, and the central dashboard is saying, yeah, you have now 180 of 200 hypervisors. And then you see, hey, it's everything green, so I can go to lunch, everything is okay. And well, 180, okay, we are missing something there, so there's this risk of high spots. It is technically solvable, but you have to think about it. So this is something we probably underestimated or saw issues in that. And the last point, I would say it's still today us creating work and effort is to define the success factors. This is something what we have with our organization. We are a large organization. We have 10,000 of people and a lot of business units using our products. And we had multiple times the situation, it feels a bit slow, your environment, and then you start the discussion, what do you mean with slow? And then you try to find metrics and you're trying to find what is hindering them about. And then you have the situation, or this is what we had, the one customer says, your new environment is great. It is really performant. Our VMs are working like a charm. We have really good KPIs. The other one is, it's more worse than everything what we had because it's super slow. And this, to match this, you need success factors. And to define this is really hard because what is the right measure to do that? The one cares about latency, the other of disk throughput, the other of CPU, and this is something which we also saw that we had to think about this early, and even thinking now afterwards or trying to add this afterwards is really hard because it's not so easy to find. There also the tuning is there also not so easy because there's no at least we didn't find the right tuning for there, so there's no default tuning to establish this. There are also there are some solutions which we think about Ceilometer, we think about Grafana metrics, we think we thought about Relay, and also they have all their part in this, but the whole end-to-end solution we didn't find yet. But it's a lesson to think about it early. And now we are coming to our scaling challenges. Yeah, we had some of them. One is the control plane reliance. So we had the issue, we used Ceph, pretty good, and had all of our VMs running on it as a storage for the VMs, and we deployed the control plane, and the control plane was also running on Ceph. No worries at all. It worked for the 98%, and then it came to this 2% situation. The storage was slow. It was not offline, it was slow. And it was not slow on every node, but some certain nodes were slow, and some disks were only slow, and we had in between also some network issues. So a really difficult situation from the operation side. This leads to us that our whole environment was, from the user perspective, totally offline. Why? Our Horizon API, or all the OpenStack APIs, were flapping because they were available, not available, available, not available. The Horizon web view, which it was used heavily by the users, was also not available. And in behind, the load balancers could not be spawned because because the VM scheduling and starting was also something. So what we did is that we moved control plane components out of the Ceph to basically local storage. This helped us a lot. Since we did this, we do not have a major incident in the control plane. Network separation matters. yeah, this is something what you have to care about from the beginning. And fortunately, this is something which is positive, but it's also a learned lesson. We did it pretty early, so we didn't have the big issues with it. But separating storage network from our networks makes absolutely sense. And there were several times where we thought, oh, glad that we did that, because that helped us in the situation to overcome. API scalability. OpenStack APIs often require review because they are designed for a certain case. And I don't know if it's a special case what we have, or if it's a general issue which is just not solved. We have few big clusters and not as might others a lot of small clusters. So this is an issue what we have, that the APIs went into problems when we are talking about scaling. We had slowness of the APIs. We had the issue that core components which are serving the APIs were slow, not reacting. We had even some bugs where we struck on. At the end, when you look in detail to these problems, you cannot narrow down them to the APIs. They were related to Neutron having a bug and creating unlimited port loops. Probably a slow network has issues. The database using that quorum and all kind of these. But at the end, it comes to the API, and the resilience of the OpenStack APIs was a bit challenging for us at the end in the scaling. And think about that and also review. Especially the load balancer API is something where we had a lot of issues and where we had a lot of incidents also related to that. And we had to review this 2 or 3 times what we can do and how we can scale up this, which measures we can take to improve the situation. And even until now, we have still some smaller issues with that. So this is definitely a challenge in the scaling. And the last part, which comes with the scaling, is keeping up with the updates. I think this is something which we do not have solved ultimately. We have our processes and improvements there, but it's still a big challenge here. The update frequency is one topic. I think it's not a big issue. We have the issue that we have so much systems to update, and automatic updates is something which we didn't manage until now to implement this in a whole. The manual part is really hard because we have to test everything, and we are a big organization with certification, so we have change processes. We have something like advisory boards, which we have, where we have to create requests when we do such a big update. And there comes a point with the overwhelming technical services of OpenStack. When we do this, then probably we are doing an update of our orchestration tool, and there it says that it's a version bump of a minor version, and then we identify, oh, okay, Neutron was new now, and we also introduced a new Nova update with that. Hopefully that will work, and 2 weeks later we identify, yeah, okay, that was that. Or we introduce a new bug. And this is something we have to care about it and to find even a better way. But it's a challenge for us, and we are very carefully now reviewing the updates and planning, but planning also that regularly. The issue with the flavors and hardware configurations. This is also a good learning we have. Flavors need balance. It's like cooking. So the name flavors is chosen very wisely from the OpenStack team. It's like cooking. So if you take a bit too many, it can destroy your evening or your night. And that's what happened also from our side, or what I would suggest to do. Think early about that. Large flavors, we identified large flavors reduce efficiency. exceed use of them can also have issues. Then we have our customer and say, hey, I have this on AWS and Azure, I can choose their 20 or 30 machine types, and here you are providing to us so few. Couldn't you add this and that? And oh yeah, we have a strong requirement, let's encrypt the RAM, and so on and so on and so on. And these are our learnings from that. So first of all, we identified having less flavors is a good thing, because from our side, the users are expecting more flavors, not because they need more flavors, but because they think implicitly, you have more flavors, with a higher flavor, I get more power because I'm getting a dedicated node, because there are not so many nodes with 64 gigabit RAM, or having them in between, they expect to have less cost or something like that. Normally, all the reasons which they said to us, which are the reasons why they requested it, were not really there, and with some explanation they understood that they, with the existing flavors, they are also possible. The next thing is keep CPU types consistent. I think this is also a crucial part, but it's not so easy to stick to that, because sometimes servers are bought in a big amount, and then you are talking about prices, costs, and buying teams, and teams who are negotiating prices, and then someone says, hey, we can get this from another vendor, but just a little bit different CPU for the 30% price degree, let's take this. This could be a decision which can limit you. Ultimately, it can lead that you are not able to offer live migration before, because when the CPU types are too indifferent from each other, and the CPU features are deriving too much, always the least or the weakest options will be chosen as a common understanding between the CPU types. That's something we also experience and would like to share. And the next point is hardware level settings. As said before, there are some tweaks you can do, and you can get a bit more performance. I heard also some talks about that in the AI context today. But even in the classical way, where you can get with some configuration a lot of more performance. But you can do also otherwise. So configure and get less performance, that's an issue. And if you tweak too much and have such a big CPU landscape like we have, or such a big amount of CPU nodes in one cluster, it can be very challenging to find for the scheduler the right node to address your machine. The last one is provide specialized nodes. So when you have these cases that, for example, they need a node for a database, then try to find a group of CPU nodes which you want to provide and offer them. Because hosting in a Kubernetes cluster needs different kind of CPU allocation as a database. Yeah, at the end, what also came in our lessons learned is to pay back our technical debt. So I think nearly everyone was in this situation. We need to take technical debt. We do not want to, but we need, because it's always about time and money. And the ideal path is to avoid this. But when you not avoid this, think directly how to start a payback plan. So how to plan in your development and in your further evolvement of the platform. When do you cover up the topics which you left behind? We experience really good with architecture reviews. Regular is the hard word for this, because we are not doing this every month or every 2 weeks. Yeah. So, oh, thanks. Yeah. And keep an eye on development. So some technical issues will be solved for the community. Another topic, I will rush a bit to the last topics because out of time. So CI/CD testing. There are some big challenges for us. Having a central repo, because we want it, was a hard decision and also has some implications with us, which can create issues. Testing is something which is very crucial, but for that also don't forget the user. So we can test everything, all APIs are okay, but if you cannot leverage a VM and access this VM through a load balancer, for the user this does not exist. And the pipeline, I think we're aware of it. Yeah, that was it.